I guess on the last few slides there, you're kind of showing flat 2D drawings of landscape layouts. In essence, that's what they are. So, it might be something you could give to a builder or a paving person to show how they want the pavers built and laid out. So far we've been mainly talking about design and 3D design. Moving into documentation, you had to work through some challenges on the 6 and 8 Parramatta Tower project. Could you share some of those experiences and how you dealt with it?
Yeah, I think look, moving into documentation is a key area, I think, and an area where I think computational design can really be undervalued by some. I think there's some challenges in it though that sometimes make the process. You need a bit of process thinking to get efficiency out of it, especially on a job like 6 and 8, say Parramatta Square. And what we found is it becomes a numbers game sometimes of what you're trying to do. For example, here's a shot of the actual tower itself with that Excel coloured polygons placed back onto the building itself. But what it is about 8,000 polygons in this building, so which means sort of 8,000 facade panels we have to apply to it. And now what we did is we actually did take our G&T sort of libraries of facade components and actually place them on the building. And I'll show a quick video of that sort of starting. And last year, I think we presented some things showing how we're going about this process. And look, it was very effective and it worked very well. And the only downside to this process is it, because of the sheer number of elements, it starts to build up over time. And I think it took probably the best part of a week, I think, to get through the entire sort of 55 stories of the building. Just using one computer, we weren't sort of farming it out. We were just letting it run in the background and other things. So, and look, it could have been a reason because the way we actually built the panels or some other items along the way. But it faced some challenges along the way. How can we make that more efficient? And so that was one aspect of it. The other aspect of that sort of process was the model size and export, the quality that we were getting. We were part of a large team. We're part of a larger team on this project that require IFC exports for this one. And the nature of the panels that we'd actually created using the G&Ts were they're exported as individual pieces, not full facade panels. And so it took a long time to export, and the quality wasn't there for the overall team. So on other projects, what we've been doing is looking at how can you use cells to address this and placing it, and they're much smaller buildings, so the amount of cells are much lower. But that addressed the issue of time, model size, and also the export quality, having it as a cell. But the idea was how do you apply that to a building that's got 8,000 facade panels and would have various sort of iterations of those panels that you'd have to create as cells. And so I think the solution for us started in the data that we actually have. So here's an example of sort of an Excel dump from, I think it's level 29, color 186. So we colorized obviously the polygons and we split them by levels as well. And it turns out that GC can actually be used to process large amounts of data via Excel to produce a more streamlined approach for us. So the advantage of using GC for this rather than using, say, just Excel to work out the numbers for us was that within GC, you can actually utilize other nodes or other building information. So you can access, say, the building type itself, or in our case, we're looking at the level manager and pulling out the levels as well. So you can integrate both node information as well as Excel information within GC. And so then it was a matter of just using some really quite simple script, really. We're just looping through each of the data within the Excel that we'd sort of brought into GC, trying to find unique panels. And so what actually happened was, out of those 29, the system could narrow it down to say, here's the 4 panels you actually need to make up those 29 panels. And you can see here, we also went down to the level of picking out left and right angles, so looking at the panels next to them to work out whether the panels were at 90 degrees or any other angle, because we had certain other angles around the building as well. And then we could actually take this sort of unique data and then put it back and use it to create the cell library for us. And it actually, so if it was a 90 degree panel, then we could actually splice the corner panels and things like that. And then So then we can automatically create these facade cells. And then using that main master Excel file, then we can actually place them all back onto the building again. And the result is something that looks very similar to the one we had in the G&T world, but now we've got something that's a bit more robust in its export and a lightweight sort of model, I suppose. So another area that we're sort of looking at is during documentation is repetition. So anytime you can sort of, come around and sort of reduce the amount of repetition you're doing every day is a welcomed approach, I think, for everyone. And if you look at, say, that paving pattern we did before, we definitely looked at areas where if you're labeling paving like this is just a quick example of what's possible, I suppose. And what we've done in the past is if we had to label paving based on its size, it's a very quick process. Even if it's not modeled in GC, it'll just label it for you, which is fantastic. So other areas we're looking at is how do you drive updates using GC? So things like dynamic views, how do you update those? So on the Singapore competition, for example, we had changing diameter of the building. So our dynamic views, we had an unwrapped elevation of the internals of the project. And then what we could do is link it to those dynamic sort of diameters of the building, and it would automatically update our dynamic views for us. Another area we like to use is any repurposing of data we can. So key areas like, taking 2D site text, turning it into meshes. I think everyone's seen some of those examples before, or even just taking those meshes and then labeling them. I think is always a welcomed approach to anyone that's working on a documentation project.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.